Hello, this is Duncan Fowler, and we're going to talk about today Introduction to Sustainable Engineering. With a lot of information and stuff, there's an expiry date. How long that information is true and accurate. Maths, 2 plus 2 is 4. It's always been 4 and won't change. And other things as we become we understand the topic more, some of the information might become outdated. So that is the disclaimer on this presentation that as of today, which is November 2023, this information was correct, but it may not be in the future. My recommendation is to use this as a starter for your research, but do your own research. Check the information is still accurate. Also, in this topic of sustainability and eco-engineering, it is quite easy to slip into a sort of preacher getting on your soapbox um, uh, performance and stuff, and I'm going to try very hard not to, and if you do think that, I apologize. So sustainable engineering can be defined as the application of engineering principles and practices to design, develop and implement solutions that meet present needs without compromising the ability of the future generations to meet their own needs. That's sort of a mouthful and stuff. Hopefully we'll get further into it. So, but it involves integrating economic, environmental and social considerations throughout the entire life cycle of a product, process or system. It's the entire life cycle, not just the middle bit where we manufacture it. Where did that material come from? What happens at the end when that product has served its purpose? Where does it go to? So it's an entire life cycle. And so life cycle assessments, LCA, you've got to understand the concept of LCA. Its application is evaluating environmental impacts of products and processes and its roles in sustainable design and decision making. So there's going to be lots of presentations we're going to work through. I'm going to look at how product is designed, what materials it should be using, and give some examples maybe on electric vehicles and battery life and stuff like that. But for today we're going to concentrate on just a general introduction. So life cycle assessments, various environmental impacts and categories such as greenhouse gases, emissions, energy consumption, water usage, air pollution, land use and toxicological effects. It's more of an holistic approach as well that goes beyond the single impact, allowing for a more comprehensive understanding of a product's environmental performance. So it's from sourcing the resources to the process to the manufacturing, then we distribute, then we use the product, and then what happens to it at the end of product? Can we recycle this product, or does it go to a landfill? Sustainable engineering, we're looking at renewable energy systems, sources such as solar panels, wind, hydrogen, geothermal energy, their technologies, integration into the grid as well. Again, do your own research on this. So some people will argue that solar energy, when it's being used and it's installed, for example, on solar panels on a roof of your house, that can be seen as environmentally friendly, but where did the products come from to make those solar panels? When you finish with them after 25-30 years, what's going to happen to them afterwards? So as we get better at creating solar panels or electric vehicle batteries and stuff, from lithium batteries to sodium ion batteries or things like that, things will change. Energy efficiency and conservation. We're going to examine strategies to improve energy efficiency in buildings. We see when going to new buildings now, or even old buildings, we see the graded to see how energy efficient they are and stuff. And so are household products now. When you buy a washing machine and stuff, they're graded. So it's important to industries and transportation as well, how we look at all of that, including energy audits. So companies are very um, um, understanding and take note of their energy audit because it costs. Uh, and it's also harder now to retrofit things. If we build in these systems when we're building new houses and stuff, it's obviously easier. And as um, we start getting smarter, the smarter systems and factory of the future and Internet of Things, we can react much quicker and get data quicker, and we can start changing our behaviors and stuff. So sustainable water management, water scarcity is a major issue, water treatment technologies, wastewater management, water conservation, and the importance of sustainable water practices in engineering an issue, and it's something if you're working at a company you would need to take into account. Also, green building design, sustainable building design principles, green materials and technologies, energy efficient systems as well, passive design strategies and certificates like the LEED, which is Leadership in Engineering and Environmental Design. These are all part of sustainable engineering. Sustainable transportation analyzes sustainable transport systems, including electric vehicles, public transport, alternative fuels, integrated transportation systems, and the potential to reduce greenhouse gas emissions and improve air quality. It also involves circular economic and resource management, which is exploring the concept of a circular economy, waste management strategies, recycling and upcycling, sustainable materials selection and resource optimization technologies. So this recycling is becoming more and more prevalent in our everyday lives. Not enough at the moment. If you look at the number of times we replace our mobile phones, what happens to those mobile phones and stuff? A lot of people simply put them in a drawer somewhere, thinking that one day they might use it. Whereas if we had more recyclable thoughts at the beginning when we're designing these things, we could reuse the raw materials. So sustainable manufacturing industry processes include sustainable manufacturing practices, cleaner product methods, industrial ecology, waste minimization, eco-industrial parks, and the role of engineering in improving industrial sustainability. So we're looking at the process optimization, we're looking at energy efficiencies, eco designs. How do we design a product through maybe material selection um, and transportation costs and stuff to reduce its environmental impact. And this concept in industrial symbiosis as well, and waste reduction. We also have the environmental impact assessment, which is a conducts understanding the process of conducting EIAs, including identifying and evaluating potential environmental impacts of engineering products and exploring mitigation measures and sustainable indicators. So we look at things like who are the stakeholders, industrial, institutional change, how we can change things in a company, corporate change, which goes throughout the company. It needs to start from the top, but everybody needs to be involved in it. The idea of design and engineering change. So, we'll be talking later on in the presentation on designing for eco-engineering and scientific changes. We could be knowledge, information becomes available to us. We might be changing things due to more knowledge on how to do things better. Sustainable infrastructure development, covering sustainable urban planning, greener infrastructure, resilient design, sustainable transportation systems, water and water waste infrastructures, and the integration of nature-based solutions. And so, environmental viable, natural environment, sustainable economic development, economic sufficient economy, economy, uh, equitable social environments, nurturing communities as well. All of this is part of the sustainable infrastructure and development, as well as social and ethical dimensions of sustainable engineering. Obviously, with the social and ethical dimensions, we're examining the social, cultural, and ethical considerations of sustainable engineering, including stakeholders, social justice, equality, and the role of engineers in creating a sustainable future. And this is not just within your factory, it's where you're sourcing the materials from, whether it's within locally or it's across the world. We need to consider how we're getting that material to the company. Transportation, where does the material come from? Is there any local environmental issues that we need to be aware of? Adaptation versus mitigation. So, climate change mitigation and adaptation addresses the challenges posed by climate change, exploring mitigating strategies such as carbon capture and storage. That, that that's a good thing to be doing, but it's not going to answer the problems. We need to be looking at renewable energy development and adaptation measures to enhance resilience in the engineering products that we produce. And this goes through policies and regulatory frameworks. This includes international and national policies. So it's not just you working at your company, but it's you're driven or you're restricted within your design and manufacturing processes by the government policies and regulatory frameworks, which you have to adhere to. And there'll be a national policies, regulations, and standards related to sustainable engineering, and you need to understand their impact on decision making, involve innovation, and project implementation. But don't believe everything that's coming out at the moment. There's are clearly hidden environmental costs for a lot of things. That's why we need to you need to when you're doing research on environmental manufacturing and eco-engineering, you need to look where the materials, the source material comes from, and where the product finishes after it's been fully used. So what happens to where does the material come from for electric vehicle batteries, and what happens when they've you finish use with that car? What happens to that battery? So do your research and don't just accept the first thing you get. Hopefully that's a reasonably good introduction to eco-engineering. Uh, Remember that this is timely, so a lot of the things we've discussed might have changed, might be a lot more better methods of doing things than we've discussed now. But it's up to you to go away and do your own research and fact check things for the current time that you're doing your research. Thank you.